Hello pre-calculus students, and welcome to a video on simplifying trig identities. This is the second of 3 videos, and these are going to get just a little bit more sophisticated. So let's get started. So first of all, there's 2 strategies that we're going to look at here. The first thing is sometimes we want to multiply everything out first. And the opposite is sometimes true, and that's going to be the second examples here where we have to factor first. So in a couple suggested steps here, if you do recognize the Pythagorean identity, then definitely use that, because that will usually shorten something from 2 terms to 1, and we want to do that whenever possible. And then if you recognize a common factor or trinomial, then you want to factor. So that's going to come into play in the second couple of examples. So let's look at this first example. And first of all, let's be careful that we cannot use the Pythagorean identity that has the tangent, because it doesn't have a square. So without a square, you cannot use the Pythagorean identities. They're all about pieces that are squared. So what we're going to do here is we're going to do just what the directions say. We're going to multiply and then simplify. So we're going to multiply tangent of theta plus 1 times the tangent of theta minus 1. You might recognize that as the difference of 2 squares. We're going to get the first times the first is the tangent squared of theta. The inners and the outers, they're both going to be the same but opposites. So we're going to get the outer times the outer would be tangent times -1. That's minus the tangent of theta. The inners would be plus 1 times the tangent of theta. And then the last times the last is 1 times -1. So that's minus 1. And then we still have that minus secant squared of theta. And that whole thing is over the tangent of theta. First thing is to note that these terms in the middle just cancel out. And what we're really looking at is the tangent squared of theta minus 1 minus the secant squared of theta all over the tangent of theta. All right, now we need to simplify the numerator, and we are going to be able to get it into a single term without adding or subtracting. And now that we do have squareds, we have the tangent squared and the secant squared, we're going to kind of look back at our Pythagorean identities. And here's the 3 Pythagorean identities. And notice that the one that has the tangent squared happens to also have the secant squared. So we're going to use this identity. So let's go back, and we're going to use secant squared equals tangent squared plus 1. So we know we're going to use this. The secant squared of theta equals the tangent squared of theta plus 1. So I'm going to pause the video and give you a chance to see if you can figure out a way to use this identity to shorten this expression in the numerator. Okay, don't worry about the denominator yet. Okay, so I'm going to pause it and give you a chance to work on that. Okay, so there's more than one way to do this, but we're going to look at what I think is the easiest one to see, which is because this is already set equal to the secant squared of theta, we're actually going to make this numerator expression longer before we make it shorter. And in other words, we're just going to replace the secant squared with the tangent squared plus 1. So I'm going to rewrite this as the tangent squared of theta minus 1 minus, and then I'm going to replace, now don't miss the parentheses because you're not going to make them both negative here, but I'm going to replace the secant squared with the tangent squared of theta minus 1. I'm sorry, plus 1. And that's still all over the tangent of theta. All right, now if I distribute the negative sign here, I get tangent squared of theta minus 1 minus the tangent squared of theta, and then minus 1. And that's still all over tangent of theta. And now you can see what happens. The tangents cancel, and the negative ones combine. So you have -2 over the tangent of theta. Now we're not quite done yet. We can simplify this more, and I'm going to rewrite this as -2 times 1 over the tangent of theta. I'm going to use the reciprocal identity that the 1 over the tangent of theta is the cotangent of theta. So this is -2 times the cotangent of theta. That's it. Okay, our second example, we're going to have to multiply again, and that, again, you're kind of given a little hint here is that the directions do say multiply and simplify. So we're going to multiply these out. Now remember, when you're squaring something, you're really multiplying it by itself. So we have to be careful. We don't want to just distribute the exponent here. We have a middle term. We'd be missing a lot of stuff if we did that. So we have the tangent of x plus the cosecant of x times itself and then minus the tangent of x, and let's be careful here, we're subtracting this whole thing, so I'm going to put it in another set of parentheses, the tangent of x minus the cosecant of x times itself again. So tangent of x minus cosecant of x. Okay, so we're going to multiply that whole mess out, and so in the first one we have tangent of x times tangent of x, which is tangent squared of x. We have a plus, the outer is the cosecant times the tangent, and the inner is the same thing, so there's two of them, so 2 tan x cosecant of x, and then the last thing would be the cosecant squared of x. And then in parentheses, we've got tangent times tangent, which is tangent squared, minus the tangent times the cosecant, and then there's another one of those, so it's minus 2 tan x cosecant x, and then negative times a negative would be plus cosecant squared of x. Distribute the negative sign, and what we're really looking at here is, well, we can just see the distributive, so we're going to tangent squared minus the tangent squared is going to go away. Positive 2 tan cosecant minus a negative, so this is going to actually be 4 of them, right? So let's be careful here. This is 2, here we have 2, 2 minus negative 2, which is 4. So we have 4 tan x cosecant of x. And then we have cosecant squared of x minus cosecant squared of x. They also nicely cancel away. So now we're at a point where we can just simplify this by using the strategy from the previous video, which is changing these to sines and cosines. So we have 4 times the sine of x over the cosine of x times 1 over the sine of x. Cosecant is 1 over the sine. The sines cancel, and we get 4 times 1 over the cosine of x, which is the secant. So this is 4 secant of x. Nice, huh? Okay, let's look at a couple of examples where we go the other direction, and instead of multiplying things together, we factor things out. So this time we're going to factor and simplify. So you're looking at two terms here, and I kind of want to relate this to, let's say that you had x squared minus x squared y squared, and you wanted to factor that. You would take out the common factor of x squared, so this would be x squared times 1 minus y squared. Okay, that's exactly what we have here, only instead of x and y, we have tangent squared and sine squared. So hopefully you can see that the common factor here for this first example is the tangent squared. Pull that out in front, and on the inside we have 1 minus the sine squared of theta. Now 1 minus the sine squared of theta is going to simplify based on the main Pythagorean identity, which is the sine squared of theta plus the cosine squared of theta equals 1. Now if this is true, then it's also true that I can subtract sine squared from both sides. So another way of writing this would be to say that the cosine squared of theta is 1 minus the sine squared of theta. Okay, well that allows me to replace 1 minus sine squared with just the cosine and get rid of that negative sign. So I now have, there we are. I now have the tangent squared of theta times the cosine squared of theta. And now I can go ahead and use changing it to sine and cosine. So I have sine squared theta over cosine squared theta times the cosine squared of theta, and this whole thing simplifies to sine squared of theta. Okay, let's try one more example where we are going to factor and simplify. So we're going to factor the numerator here. We're going to probably try to use a Pythagorean identity on that denominator. It looks like we've got 1 plus the cotangent. Hopefully we can reduce that down. But first, I think we should factor the common factor from the numerator, which is the tangent squared of x. Let's pull that out from the numerator and rewrite our numerator, and you're going to see some nice simplification here. So just before we get started, what we're going to use is we're going to use the identity that has the cotangent squared. So we have the cotangent squared is the last identity. Cosecant squared equals 1 plus the cotangent squared. So we're going to use the cosecant squared of theta equals 1 plus the cotangent squared of theta, and that's going to allow us to rewrite our denominator. Okay, so the numerator, though, going back to the numerator, take out that common factor, tangent squared of theta times the sine squared of theta plus the cosine squared of theta, except that they're x's. So let's just kind of make them x's. It really doesn't matter, but we don't want it to look weird. Okay, and then over what? Well, we know from here that 1 plus the cotangent is just the cosecant squared, so we can rewrite this as the cosecant squared of theta. Hopefully you recognize that there's the main Pythagorean identity here. Don't forget that the cosine squared of theta plus the sine squared of theta equals 1, and that means that this is just equal to 1. So all we really have here is the tangent squared, again, I did it again right here, that's an x, tangent squared of x over the cosecant squared of x, and we can now just use that original strategy of changing it to sines and cosines. So we have the sine squared x over the cosine squared x. There's our tangent squared. And our cosecant is 1 over the sine squared of x. We are not going to get something quite as nice as all of the other answers, but it's still going to be pretty simple here. So we have sine squared of x over cosine squared of x. The reciprocal of this is the sine squared of x over 1. So we get the sine to the 4th of x over, well, actually, we can write it like that, but we want to write it as one layer, so we're not going to combine it that way. Instead, we're just going to simplify this one right here as going back, writing that as the tangent. So we write this as the tangent squared of x times the sine squared of x, and that's as far as we can go. Still a single term, no pluses and minuses, and no layers, no fractions, and that's as simplified as we can get it. Okay, hope you found this video helpful.